Hello everyone, today I'll be going through the math method 3 for worksheet 5, and as for usual, the answers are on the screen right now, so go over them if you guys want. And okay, cool. Okay, let's start going through them. So for first I actually need to correct something. Instead of this being take free, it's actually take active, so I'm not gonna write active, but yeah, basically this is take active and we're allowed to use calculators. So first step for question 1, when we see intersection, we equate the two equations together. So we get 2 sine x equals to a cosine of 2x, and then we sub in x equals pi on 6, so we get 1 equals to a on 2, so a equals to 2. With this, we can equate the two equations again with a being 2, and then we can cancel out 2 on both sides, and we can solve this equation on our CAS with the domain from 0 to pi. And other than getting the intersection of x equals to pi on 6, we'll also get another intersection point at x equals to 5 pi on 6 and 1. So we'll pick up C for the question 1. Question 2, so how I would like to graph this is that I would just graph all 3 equations in the CAS and see which one looks similar to this. But if you want to do it by hand, first we can try subbing points. For example, if we want to sub in 0, 2, we can immediately eliminate option B as that doesn't fit. And if we graph rest A and C on our CAS, we can kind of see that they're actually the same graph. So yeah, therefore the answer is A and C. For question 3, this type of question, we could also just define f of x equals to e of x, and on CAS we'll type each of these in. And if we get true, that means it works. And if we don't get true, then that means it doesn't work. But in here, it's kind of obvious D is the wrong answer because f inverse of x is log e of x, or ln of x. Yeah, so it's ln of x, and that's clearly not equal to 1 on e of x. Therefore, option D is definitely wrong, and that's why we'll pick up option D. Okay, so question 4, I kind of have my working out here. So A is equal, because everything is in log B something, so we want to put A into the form of log B something as well. So 8 is equal to log B of 8, B8, so it's in this form. Therefore, if we move the 4 on the, so move this 4 on the top here, we get x log B to the log B and x to the power of 8. So since everything is in the form of log B, now we can cancel log B to get x to the power of 8 is equal to 16 times B of 8, because log B is cancelled out, so we just get B to the power of 8. And then we can evaluate this to get x is equal to plus minus square root of 2 times B. So that's A. For question 5, this is a general rule that we have to remember, that if we have log of xy, it is equivalent to 1 on log yx. And if you want further proof of that, maybe you can try to prove this yourself with something called change of base. If not, feel free to let me know on WeChat and I can send you a proof. But if we convert both of these into this form, we'll get B as the answer. So yeah, we'll pick up B. And question 6, usually when we see this, the slow way is to try all of these graph out, but the quick way is to realize that this question is basically asking which one of these is an odd function, as that's the condition for an odd function. And we can see only this satisfies the odd function. Therefore, we can pick up E as the answer. And question 7, this is an application of the chain rule. And when we're using chain rule, we're taking the derivative of the inner part, which is here, f dash of x. And well, keep in mind the inner part's derivative is -2 f dash of x. But since we have a square root here, which is saying this thing to the power of a half, we have a half times 2 on top. So that kind of cancels out. So we don't actually need to have 2 here, basically. Therefore, it's just negative f dash of x on the derivative of this, because this is basically writing this below here square root is basically writing this to the power of -1/2, and a half minus 1 is -1/2. That's why we pick up C for this. And question 8 is definitely a calculated question. What we will do is, since we're looking for the volume, so the volume of a rectangular prism is just length times width times height. So we will times all these together to get a function. We can say like v of x would equal to all these times together. And we will just take the derivative of that function and make it equal to 0. And we will subbing the x value to v of x to get the maximum volume. And in this case, it's 70 units cubed. Okay, so now we get on to the short answer questions. So question 9. First, when we're solving for these equations, I like kind of working out the period first. So we have 2 pi divided by 2 pi on 3, which gives us 3. That means that means one period is 3. And since it tells us it's from x element from 0 to 3, which is also 3, that means it's asking us to solve for the solutions in one period, which means that there's 2 solutions possible for this equation. And then we can kind of, with the domain given, we can kind of chuck this in the middle. And since we know it's the one period, we can kind of just try out, because usually for theta is equal to negative 4 pi on 3 or negative 5 pi on 3, we will get sine of theta is equals to negative root 3 on 2. And if we just sub this value, if we equate this to 2 pi x on 3, we'll just get x equals to 2 and 5 on 2, which is within our domain. And that's the answer for this question. And for the next one, the working out's kind of here as well. We're just subbing all the transformations. And we're looking for the smallest positive value for this is a maximum. And in the case, when we're looking for the maximum of a trig function, we'll always make the trig part, aka in this case, like sine of everything here, we'll make this equal to 1, as that will give us a maximum value. And for a sine of something equal to 1, the inner part has to equal to pi on 2, right? So we'll let pi on 2 equal to the inner part here, and we solve for x, and we get x is equal to 7 on 3. And we know this is a small solution because the period of this equation is 3, and 7 on 3 minus 3 is less than 0. Therefore, we know that x equals to 7 on 3 is the smallest positive solution for this question. Next one, we will have, so this is another mistake here. This is, let me quickly correct this. Actually, no, f of x is right here, but down here is, q of x, I'm pretty sure. Yeah, so this is not f of x, this is q of x basically. Anyway, okay, so first, the way to determine these equations are, we know this is a truncus, so it will have a general form with y equals to a over x minus h squared plus k. So that's the general form of a truncus. And we know if there's a asymptote at x equals to 1, then we know that the h value is minus 1, because that would then we're shifting the graph 1 to the left. And we know the horizontal 1 to the right, sorry, and we know the horizontal asymptote is at y equals to 0, therefore k is 0. So now we just have y equals to a on x minus 1 squared, and it gives us a 0.02. We can just sub that in, and we will get f of x is equal to 2 on x minus 1 squared. So that's the answer for this. For this one, we know there's an asymptote at, x-intercept at x equals to -1 and x equals to 1. But notice how it, when x equals to -1, not -1, sorry, when x equals to +1, it is also a turning point. So we will know the graph will be in a shape like this. So it's a of x plus 1 times x minus 1 squared. So that's a general form, but we don't know what the value of a is. But again, they gave us a point of 0 and 2. We can just sub that in, and we'll get not f of x, sorry, q of x is equal to this. That's our answer here. And this is why we need to change f of x, q of x. Basically, the question below asks us to ask that p of x is equal to log e of q of x plus f of x. So when we see log e of something plus something, we can immediately know, use log rules to equate them, times it together. So if we times this function here with this function above here, then we can notice the x minus 1 squared cancel out. So we'll just get f of x equals to 4 of x plus 1. And that's p of x basically, which is what this question is asking for. But now S is the hard part. S is basically the domain of p of x. And we know that for any log graph, any value below 0 wouldn't work. So we already know the lower part of the domain is -1 exclusive, because if x exclusive equals -1, then, well, we wouldn't have then we will have 0, which makes this undefined. But what about the higher value, like higher value? Traditionally in this graph, it's infinity, but in this case, we have to consider the domain of the previous two functions. So if we look at function f here, its domain is real, so we don't really have to worry about that. But if we look at this function here, we see that at x equals to 1, there's actually, well, there's actually an asymptote here. Therefore, x can't be 1. So therefore, the domain for this function should just be -1 to 1. And the 1 is exclusive, basically. And given this domain, we can work out the range of p as x approaches -1, we will get the whole graph approaches -infinity. And as x approaches 1, the graph is approaching log e of 8. And that's our range for this graph. And usually doing these questions, it's better to check on CAS after to see that the endpoints are actually approaching our domain value. So like, for example, in this case, it's kind of lucky because the log graph looks like something like this. So the two endpoints are like its smallest and biggest value respectively. But if we have a graph, for example, like something like this, then you can see here, yes, this endpoint is smallest value, but we have a large value somewhere else, which will change the graph's range. So it's always good to graph this back into CAS to check if our endpoints are actually the like biggest and smallest value, which defines range. Yeah. Other than that, that's that's our question done. And here's the actual answers at the back if you want to look at these. All right, cool. And yeah, one last thing is just that the study hub is also running every Tuesday from 6:30 to 8:30. If you guys have any questions regarding this worksheet, feel free to comment. I'll be there to answer them.